Hi everyone, this is Mikey N6IL, and today I'm going to do a little video about the Southwest Technical Products 6800 computer. A couple of days ago, as you see about 3 days ago, Adrian from Adrian's Digital Basement did a video about this computer. And I've been playing with Mame a lot, and I like playing around with Mame and different hardware that it has in it. So I was curious to find out whether I could learn anything about this computer. So, as I sometimes have been doing a lot lately, I've been using this site called the Arcade Italia database to find out about different machines. And I just typed in SWTPC, which is the Southwestern Technical Products Company, and out popped the SWTPC 6800. They even have a little picture of the machine here, which is cool. So yeah, this is absolutely the machine we want to play with. So using this database, we can learn quite a bit about the emulation that's available inside of Mame. One thing that's important that we can see is we have good emulation, good graphic. Well, it doesn't really have color, sounds, any of this stuff, but overall it says the emulation status is good. So that's a good sign. Um, so what uh, ROM files do we need for this? Required files. Basically says we need a ROM file of swtpc.zip. We will take a look at for that in a moment. Yeah, SWT bug. All right. The other important thing that we can do here is they actually display on the screen the XML information for this MAME driver. And when you're playing around with different systems in MAME, it's a good idea to look at this so that you understand how the machine is configured. There is actually a way to look at this from the command line, but this web view is actually a little bit easier. So it's the SWTPC 6800 with SWT bug. All right, here's the ROM that we were talking about. Now it actually shows a list here of all of the possible devices. It has SS50, which is the bus interface that Adrian talked about, RS-232 serial terminal, it has PAAs, it has floppy controller, so it has a CPU at 0.9, just like, looks like a little bit faster than the color computer, 0.9 megahertz. Looks like it has a display, which is the RS-232 terminal. Let's scroll down a little bit to, we don't really care about all these configuration values. They're good to know, but we want to look at the actual hardware that's connected to this machine. So the way that we do that is, okay, they have, if you look at this, they have slots, and they have the name of the slot IO0. So IO0 does not seem to have anything attached to it, but IO1 has an MPS card, which is the serial card which Adrian showed. And then IO1 has an since it's a serial card, and it has an RS-232 port, and by default that is connected to the serial terminal. But we can connect it to a bunch of different things, and we'll actually play around with that a little bit later. What else do we have attached to this machine? In slot number IO4, we have an MPT card. And in slot number 5, we have a DC5. So this is a DC5 floppy controller, which there actually is some information about this floppy controller. We can look at that in a moment. But most importantly, it has this DC5 controller has four floppy disks, the default, and they have different formats. You can have 8-inch, you can have 3.5-inch, you can have 35 track. Looks like the default one is single-sided, single density, 35 track. Okay, and etc. for the other floppy drives. And it has a default of 32K RAM. So we learned quite a bit about the configuration of this machine. So what's next? Well, um, let's just try firing it up and see what we get. Okay, so what I'm going to do is very simple. I'm just going to type Mame, and I want to, yeah, we want to look at the ROMs a little bit. So SWTPC list ROMs. So it's basically saying it's looking for this like we saw in the XML, it's looking for this SWT bug.bin. Now, I do have that file. It's on my other drive here. Okay. So if you take a look at this, there's two different ROMs here. There's definitely the SWT bug.bin that we need. So theoretically, we should be able to run this and it should pop up and run the computer. So let's go ahead and try that. Mame SWTPC. And there we go. It's not going to be very interesting because what this actually boots into is a monitor program. So I can, for example, um, just do something dumb like RTS is 39, and I can actually go to this. Oh, it's actually trying to do something. I made a mistake. Oh, reset. Okay, let's try to do the correct thing this time. We can just jump to our program. I don't know what G actually does. I have to look at the instructions. I can go to there and it just returns because I just put in RTS. Now, how about an operating system for this program, for this computer? Turns out there's a whole wealth of stuff available for this computer. They had Flex, and I found this site called DRAMP where you can download a variety of different disk images. I have gone and downloaded this Flex 235 disk image, and I'm just gonna whack it in there and see what happens. So let's get that attached. File Manager, floppy disk. We need to go to, not here, but demo, SWTPC, and here's my disk image. It's okay, this is a copy, we just downloaded it from the internet. So, let's try to boot from the disk. That doesn't seem to work. Maybe try it again. Uh, this really doesn't seem to be working very well. So I did some searching around about why the disk doesn't seem to be working, and I found something interesting. Bootloader program. The floppy disk boot code in SWTBug doesn't work as well as it should. Here is a better bootloader, and they have the source code and the S1 format. So let's go ahead and look at the source code. This isn't very long. We might be able to actually enter this and get things started. So let's see if we can't get this set up so that we can try entering this program. Okay, so let's get ready to enter this listing. Have the listing on the right. I have the terminal window over here. So what we want to do is edit memory starting at 0300, and then we very carefully go through this program line by line, enter all the hex as best that we can, and we are at 315. Oh, we just made a mistake at 315. So let's start at 315. Okay, so 315. We have 8D to C. Now that the program has been entered, let's zoom into this and get it booted. All right, let's go. Jump to 0300. You guys can't hear it, but the disk is busy disking. And it looks like we have successfully loaded Flex 2.0, 032922. And we have loaded the Flex operating system. So, what can we do? Let's check the date. March 9, 1922. Haha. I don't really know that much about Flex, but um, it looks pretty cool. But yeah, we got this loaded. So that was quite a lot of work to type that program in. So what can we do to make it go a little bit more easily? There actually is something that we can do. And it's using an advanced and not very well documented feature of Mame. So let's dive into that. Okay, so now let's talk about what we're going to do next. If you remember when we looked at list slots, I think it was. If we looked at list slots, remember that there is a in IO1, it'd be better if we did list XML. So IO1 gets slot. Come on. There you go. So slot IO1, it has this MPS card in it. And then the RS-232 port on that MPS card is connected to a serial terminal, and that's what we were looking at before. I said previously that we can connect it to something else, and we can connect it to a null modem. So if you think about the way that this works in the real world, you have an RS-232 port, and if you want to connect on two different computers, and if you want to connect them together, you usually need a null modem cable. So we have the computer with the MPS card in slot 1 with a null modem cable connected to the RS-232 port. We can do that by adding some more stuff to here. So what we want was IO1 colon MPS colon RS-232. We want it to go to a null modem. And what we can attach to the null modem is actually a bit banger. Now, what the bit banger does is it sits on the end of the null modem and it sends and receives bits. It's kind of like what you have in the color computer, the opposite end of it. There are two things that we can do with this. We can connect it either to a socket, or in this case, we're going to use a special socket called the domain socket, and we want to do temp SWTPC. So this is a special kind, in this case, because on Linux, it's a special kind of socket called the Unix domain socket. So when we run this, if I have entered it correctly, what will happen is the computer will be running, but we will no longer have the terminal. The terminal will no longer be connected to it. Instead, that terminal is connected through this null modem, through the bit banger, to this special socket. And when it comes up, looks like I made a minor mistake. One moment, please, while we get this straightened out. Okay, it's actually called IO1 MPS RS-232 with no underscores. So let's fix this. All right. So the emulation is running, but it says there's nothing attached to the system. So what do we do now? Well, this is actually a server sitting on this special socket. What I can do, and I know exactly how to do this on Linux, I do not know how you can do the equivalent of this on Windows. That would require some additional research. But what I can do is Minicom terminal program can actually connect to a Unix socket. And this is how we specify what socket it's going to connect to. And when I run this, I'm now connected to the same monitor that I was using before. But now I'm doing it through, remember I did this same, we need to do capitals. I did this same example before, just the RTS instruction. And I can actually jump to the RTS instruction. It works fine. So back in the old-fashioned days of computers, one thing that people frequently did is they loaded paper programs from paper tape. Now we can do an equivalent of this. let's go back to our website for a minute. This is the actual assembly listing, but they also have what's called the S1 format. So this S1 format is what you would have written out to paper tape on your big computer, or your write it out on your teletype machine, punch the tape, and then you would play this tape back into the computer in order to load it in. So we're going to do exactly that, but we're going to do it using Minicom. So there is one tiny bit of setup that we have to attend to before we attempt this. No, I don't want to send right now. I want to look at the settings. So look at file transfer protocols. We are going to be using, oh, this doesn't actually have it and it works fine. Okay. One of the things that we probably want to do is, reading from uh, the computer, reading ASCII text is probably not the fastest thing in the planet. So if you're sending in programs over the serial port, it is usually a good idea to add some delay in between, so -C and -L. Add some delay in between each line and in between each character. This gives the thing on the other end a little bit of time to process each character. So it's not currently configured, and we're going to have to do that. It is called ASCII, and what we want to do is for each character, let's say we want to add 50 milliseconds. And for each line, let's say we want to add 100 milliseconds, just to slow this down a little bit, to give it a better chance of the other end receiving the characters. So this is actually running at, I neglected to show this, but this is actually running at 9600 baud on the emulator side. And on this side here in Mame, if I actually go to the machine configuration, you can see that my RS-232 port null modem is at 9600 baud with no flow control. So it's reasonable to expect that this computer that we're talking to can't actually receive the characters that quickly. So we don't need to change any other settings here. Okay. I'm going to go ahead and save this and then exit. All right. So now we're all set. We have our S19 file, which I already have downloaded. We have our paper tape, quote unquote paper tape at the ready. So we're going to tell the monitor that we're going to load the program. Capitals, load. Okay, now in our terminal program, we send ASCII and we go to demo lowercase SWTPC, and I have this boot file right here, and I hit select the file, hit OK, and it's slowly transferring the program to the other side, and now it's done. If we actually check the memory at, I can bring the program, bring the listing back up just to make sure that it actually looks like it's here, but it is. Yeah, it actually has the instructions how to how to load it, we can see B680, B68018, etc., right? CE 00000809. Okay, yeah, it looks like our program is here. Okay, so we have a loader program. We loaded it in from the paper tape. It's into memory. We're almost ready. Let's make sure we have a floppy disk. Okay, we have our flex system disk here. Is in floppy drive 1. So let's go ahead and now we run the program which we just uploaded through the paper tape, and that will supposedly boot from the floppy disk and boot flex just like we did the other way. So let's jump to 0300. And you guys can't hear it, but the disk is disking right now. Yep, looks like it's working. And now we're talking to the emulated computer. This is almost identical to what you would be doing using the real computer. And it's completely done through emulation. So thank you for uh, thank you for March 29th, 1922. We're running Flex from the past before it actually was created. All right, there was one other thing that I did. Dump. Thought was interesting. This is just dumping one of the commands. And it displays all the hex on the screen, blah, blah, blah. All right. So this is my demonstration of how to get Flex booted on the SWTPC 6800 emulation running in Mame. So at least the computer is booted and we have a way to do stuff with it. Actually now we have a way to upload and download programs from directly into memory, and we have a way to boot floppy disks. So this is actually pretty functional. All right, that's all for my demo. Bye for now.